Hi, chemistry students. This is your Unit 2 lesson on accuracy and precision. Take a look at this slide. It shows three targets. In the first target, you have a bullseye that is red, and you have 5 yellow darts that have been thrown at the bullseye. You can see that whoever threw these darts threw in approximately the same place, but missed the bullseye. We say this is low accuracy and high precision. In other words, you're trying to get to the bullseye. He didn't do that. That's low accuracy. However, every dart he threw landed in very similar position, and that means high precision. Let's look at the second target. In this case, he got a lot closer. The 5 darts were much closer to actually hitting the red bullseye, but they're all kind of spread out. So we would say this dartboard represents higher accuracy, but low precision. And then the final dartboard, you notice that he's hit the bullseye or she's hit the bullseye each and every time, and that the darts are very close and they're all on the bullseye. So this would be the highest accuracy and high precision. So let's define accuracy and precision based on this understanding. They're not interchangeable. So here are the definitions that you will likely want to write down. Accuracy is a measure of how close a measurement comes to the actual or true value of whatever is measured. Precision is a measure of how close a series of measurements are to one another. So accuracy is a measure of how close a measurement comes to the actual or true value of whatever is being measured, how close you come to the bullseye. Precision is saying a little bit about your repeatability. It's a measure of how close a series, notice a series of measurements are to one another. Okay, so test yourself here for a minute. Can you have a single measurement that's accurate, that hits the bullseye? The answer to that is yes. You could have a single measurement that hits the bullseye. Can you have a single measurement that is precise? Now, think about this. The definition of precision is how close a series of measurements are to each other. So in this case, no, you cannot. So let's look at this particular problem. Sam weighs a mass of known weight of 50 grams. So in other words, we know this weight, like maybe it's a calibration weight for a scale. To make sure the scale is reading correctly. So Sam weighs a mass of known weight of 50 grams on an analytical scale that he has not calibrated recently. He weighs the mass 5 times and gets the following readings: 150 grams, 151 grams, 149 grams, 150 grams, 150 grams. What can you say about Sam's scale? Well, let's look at it. So you'll notice that I'm supposed to have a mass of 50 grams. That's the weight that we know our calibration weight is. Now, scale he possibly suspects is out of calibration. So he puts the weight that he knows is 50 grams on, and he gets 150 grams. And then he puts it on again, and he gets 151 grams, and then 149, 150, and 150. Well, is that scale accurate? Are any one of these measures accurate to 50 grams? No, it's not accurate. However, is this series of measurements similar to each other, really close together? Well, they're within 2 grams of each other, and it's 150 grams, so they're pretty precise. The series of measurements is close. So we would say Sam's scale is what? We would say Sam's scale is precise, because they're close together, but not accurate. Now, evaluating accuracy and precision. To evaluate the accuracy of a measurement, the measured value must be compared to the correct value. So that means we know the correct value, okay? To evaluate the precision of a measurement, you must compare the values of 2 or more repeated measurements. But we don't necessarily know if those measurements are accurate. Think about the scale from the previous example. Now, to calculate the error, the accepted or theoretical value is the correct value based on a reliable reference. Like we've looked up the boiling point of water and we know that the thermometer should read 100 degrees Celsius. The experimental value is the value measured in the lab. Okay, we have boiling water that we know should boil at 100 degrees Celsius, and the thermometer that we're using says that it's boiling at 80 degrees Celsius. Well, there's clearly something wrong with that thermometer because we know water should be boiling at 100. Now, the difference between the experimental value and the accepted value is called the error. It's just a subtraction, and you could actually have this go either way. I mean, if it was 80, then the experimental value would be 80 minus the accepted value would be 100, would be minus 20. Let's suppose instead the thermometer read 120 instead of 100. The experimental value would be 120, the accepted value would be 100, and then it would be 20. Sometimes we usually just talk about the absolute value. So in both cases, that would be 20. Now, the percent error is the absolute value of the error divided by the accepted value. So in other words, we take that error, like 20, and we divide it by the accepted value, which is 100, and you get that your percent error is 20%. You multiply it times 100. So you're going to get some practice doing this, but that's the equation to figure out percent error that you should know. All right, so let's try a few things. A scale that needs calibration records a standard weight of 150 grams to weigh 155 grams. So we've got a weight, we know that weight weighs 150 grams, it's been calibrated, but when we put it on our scale that we think is a little bit off, it says 155. What is its error and what is its percent error? So the error is just the experimental minus the accepted. So the experimental was 155, that's what our scale said. What's supposed to be is 150, so it's off by 5 grams. And then we want to figure out the percent error. Well, the error is 5 grams. What the accepted value was supposed to be was 150 grams. So we have that fraction, and then we multiply that times 100, and we get 3.3% error. And that's how you would use that equation. And that is the end of the presentation, and you'll get some practice. Thanks for watching.